Hello again. All right, we're continuing with our lesson on chemical reactions. We are going to do the performance task on page 245 of your Be a Scientist notebook. So if you haven't familiarized yourself with that, why don't you pause this video, read over it, see what we're going to be doing, and then you can resume the video. 3, 2, 1, pause. And I'm back. All right. Basically, today is going to be one of these, we're going to test our conservation of mass. And we are going to be conducting this little experiment by mixing sodium tetraborate decahydrate and polyvinyl acetate. Sounds complicated. Borax and glue. That's it. All right. So let me read this to you. Changes in matter. You will carry out an investigation in which you will observe a change from mixing substances together. You will then determine whether the mixture formed a new substance. Remember when we talked about the new substances, what happened? Did it change color? Go back and look at the last video that I did, or you can go back and look at my PowerPoint that I put up on my website. But changes in color, changes in temperature, steam, all kinds of things like that. Completely new physical characteristics of the new substance. You should be familiar with all that anyway. Okay, so what you're going to do is you're going to make a prediction. So look at the materials list. Let's take a look at it. Safety goggles, for me that's this. 250 ml beakers. I don't have two, so I got various. Graduated cylinder, don't have that just yet. 125 ml of warm water. 1 teaspoon of borax, or our sodium tetraborate decahydrate. A pan balance, I don't have one of those here at my house, so we have just the scale. 60 ml of liquid school glue, and 5 drops of food coloring. There's a specific reason why I chose this color. You'll find out later. Oh, now, look at the material list. We did that. What type of material do you think will be created in the investigation? Well, let's kind of look at what we got here. Of course, we've got the school glue. We all know what the glue looks like. It's almost kind of sticky. It's very viscous fluid, which means it's really thick and it doesn't drop. If this were water, it'd be dripping down and leave my finger, but right now, but we can still smudge it around a little bit. Still in liquid form. Grab me a towel real quick when you study that. Water, of course. Just water. There's nothing magical about it, just water. And now, our borax, don't need a whole lot of this, just one teaspoon. Thank you. There we are. All right, let's get this closer. It is a white powdery substance. It's more of it feels more like sugar kind of than it does salt. If I was to just make these observations to you, because you can't, it kind of salt kind of feels almost like sand, kind of bigger grainy. This is a lot smaller grains. It does feel a whole lot like like sugar. It almost has like a detergent smell to it, which is what it's primarily used for in your household. We're not going to be sniffing the glue. You don't have to. That's not encouraged. Although, when you do waft it, it smells like glue. It just smells like normal glue. All right, so that is our substances. What do you think is going to happen when we have this liquid, this white powder, and this kind of whitish, very thick liquid? Very, very thick liquid. Also, we're going to be changing the color to a little bit of green, a little bit of yellow. So you might want to consider that when you make your hypothesis. So here's your prediction. What type of material do you think will be created in the investigation? Make your hypothesis, pause your video, make your hypothesis about what's going to happen when we mix all these substances together. I'll let you pause the video right here in 3, 2, 1. All right. So the first thing it says to us, well, first off, let's just go ahead and read through our instructions before we start doing this stuff, so we know what's going on. Measure 1 teaspoon of borax and 125 ml of water in one of the beakers and stir until the borax dissolves. Number 2, record the data. Measure the mass of the solution and record the mass in the table. Remember, a solution is a mixture, a homogeneous mixture of 2 or more substances in a liquid. Here's our solvent, here's our solute. So this will be a solution when we mix that together. Record the mass in the table. Measure 60 ml of glue into the second beaker. Add the food coloring. We're going to mask that, number 4, and record our data. Pour the borax solution into the glue. So we'll put our solution and finally mix these 2 things together. Then we're going to measure the combined to see what we get. Now, here's the thing. I don't have 2 250 ml beakers. So what I had to do was, while they were empty, I masked everything. I don't know if I'm going to use this or not. I don't know. I don't know if I'm going to use all 3 of these or not. I don't know. I just went ahead and masked it just to make sure. My 1,000 ml beaker is 277 grams. My 500 ml beaker, 164 grams, and my 250 ml beaker was 97 grams. There's the data. Making sure that we have it written down beforehand, because what we're going to do is we're going to take whatever mass we have of our solution and then subtract the dry weight of the beaker, and that way we have the exact measurement of our solution. All right, so let's go back to number 1. Measure 1 teaspoon of borax and 125 ml of water right here. Stir until the borax dissolves. We do a lot of stirring as well as beating things in these videos for some reason. So let's just stir until it's all nice and dissolved. Took a little longer than I would have expected, but there you have it. There's still just a tad bit of our solute down at the bottom, but that's okay. All right, so what we're gonna do now is we're going to mass this, and we're massing this in the 500 ml beaker, which on dry mass was 164 grams. It's now 325 grams. So 325 minus 164. Gives us 161 grams of solution. So what I'm going to do here is, right here, number 2, record our data. 161 grams of borax solution. Now, being a scientist, you're going to want to go ahead and look at this and say, okay, well, what does it look like? You might want to jot some notes down in the corner. What does it look like? Well, it kind of reminds me of salt water or the superheated water that we did with the sugar. Light doesn't go through it all the way. You've got, it's not clear. So there is some light reflecting off the little bits of sodium borate in there. So, all right, so number 3, measure 60 ml glue into the second beaker. We're gonna use the small beaker here. I'm gonna take the top off. And now we can actually get a real good observation of this glue. That's about 60 mil. And see how it will still adjust to the container that it's in. So it's in a liquid state, but see how it clings to the wall of the glass beaker? That's showing how much viscosity, how thick it is. That's also showing a lot of how the substance likes to cling together to itself. It's pretty awesome. Okay, now we're just going to mix. It says 5 drops of food coloring. So here we go. 1, 2, 3, 4, 5. Stir until mixed. Jeopardy music here too, probably.
Mm-hmm. Just be sure to stir for a while.
Okay. All right. Basically, the food coloring didn't do anything but change the color of it. So that's. But it is starting to dry on the sides up here. So you want to work fast if you're going to do this. And this is something that you can do at home with parental supervision. But you got to work fast with it. All right. So I'm going to try and get as much off of the spoon as I possibly can. Just all right. Thank you. Right on cue. And anticipating my needs. That's a great producer right there. All right, so now I'm going to take the second beaker. Turn on my scale. The second beaker, 250 ml dry, 97 grams. That is 167 grams of glue, polyvinyl acetate, and food coloring. So that's 167 grams minus 97 of the grams of the dry weight of this equals, you should be able to do this in your head, 70 grams. So we're going to put 70 grams of glue. Also, again, write your observations down. That's cool too. All right, so now pour the borax solution into the glue. So we're going to pour this in here. We're going to stir well and then observe. As we see right now, there hasn't been too much reaction here. Maybe stirring will help kind of form whatever kind of reaction we're going to have. Now, as far as slime goes, there are better recipes to do online than the one in here in your Be a Scientist notebook. Especially if you want to do like fluffy slime, because there's recipes where you can use like shaving cream to make that, and that's better. But for what we're doing today, this is just about chemical reaction. Now, our first thing, when we had them separate, we had 161 grams of solution, borax solution in water. We had 70 grams of glue. And we had a grand total of 231 grams complete of solution minus the dry weight of the 250 ml beaker. So what we're going to do now is we're going to mass this again and see. Remember now, we could lose a little bit here and there, a gram or two. You know, what we're looking for here is, was there significant loss? So as I'm massing this, and I get around 328. So 328 minus our dry weight right here, 97, 1, 12. I'm right at about 231 grams. All right. And here is the result of mixing the borax. Borax with the glue. extra food coloring just to make it look better. Got ourselves some slime here. Now it's not the best quality of slime. Like I said, there's better recipes. But we can tell that it's almost, it's like in between a solid and a liquid. And when you put it down on the table right here, it still somewhat retains its shape. Gravity, you could see gravity's pulling it down and kind of spreading it out just a little bit, but now it's stopped and it's holding its shape. But if I put it inside of a cup or something like that, it would probably form to the shape of that. So I don't know. You call this a solid? You call this a liquid? What do you think? Or you could do, you know, like yuck. I'm just kidding. Anyway, gotta have a little fun every now and again. Well, what do you think? It almost looks like the color of Baby Yoda's. It's like Baby Yoda's. Baby Yoda's got a head cold. Gross. All right, so let's look on page 246. What did you observe when materials from the two beakers were mixed? Well, after stirring it around a little bit, our two liquids kind of formed into something that was kind of a, I don't know what you call this, maybe a proto-solid? I don't know. It's kind of a solid. It's not as sticky as the glue, but it's definitely not as liquidy as the water and the borax. So how does the mass of both beakers after the reaction compare to the total of the individual beakers before the reaction? Well, we got spot on. Let's see what we got here. 231 grams of all the substances combined before the reaction and 231 grams after. That's very hard to get completely 100% accurate, but in this case we got it, and that's pretty cool. Look how it's so stretchy. Now, what's really cool, and you can put this in your observation notes. Just snap this off real quick. See how it stretches if you take your time with it, but if you pull it apart really quickly, it just snaps. See it stretch, but if I do it real quick, it just snaps. That's pretty cool. It's almost like it's got a couple of different sets of characteristics depending on what kind of energy you're using to play around with it. All right, number 3. Did the reaction show conservation of mass? Explain. Well, yeah, it did. If we have the same mass of all the substances beforehand for the reaction, and then the same mass after the reaction, then we have a conservation of mass, because matter cannot be created or destroyed, simply changed. New substances are created, but all the atoms that are on, remember our equations are chemical equations, because I'm about to put it up on the screen right now. That's what we just did. When you look at the little picture that we've got up on the screen right here, the little blue, that's the borax in the water. What is happening here is it's called a cross-link bond in chemistry, and basically that's just kind of fancy words for, well, we've got this polyvinyl acetate, which is your glue, and it's got a long chain of molecules. That's what you see up in the top in the black, and that's what you see in the bottom in the black. But it is chemically bonded now with the borax that's in the middle. That's what you're seeing with the blue in this picture. And you would think, well, isn't this a mixture? Because it seems like it's dissolved in it. that's probably a really good observation if you came up with that. But however, since the borax itself is bonding to the polyvinyl acetate, the glue, it's not just dissolving in there, it's actually chemically bonding. If you can see the blue part and the black part combining on that picture, it's a chemical bond, which means it is a chemical reaction. Look, Baby Yoda, Jabba the Hutt. Man, I need a tissue. Get me a tissue. All right, so the picture's still up here now. So the blue part is the borate. It's technically called sodium tetraborate decahydrate. And the glue is polyvinyl acetate. Now, polyvinyl acetate, which is the glue, is the black part on the top and the bottom. The borate is in the middle, and it's chemically bonded. So because it is chemically bonded to that chain link polyvinyl acetate, it is actually a chemical reaction. But let's look at number 4 and think about what kind of result did we get here just by looking at it? Can we tell just by looking at it, not knowing the chemistry? Can we just look at it and see? Well, that looks pretty different than what we had before. Is it a solid? Is it liquid? I don't know. It's kind of a little bit of both. It seems to me to be uniform and of one type of thing, but it certainly doesn't look like the water. It certainly doesn't look like the borax. It certainly doesn't look like the glue, nor does it have any of the physical properties of any of those things. If you look at it and you investigate and you make this stuff at home and you play around with it a little bit, you're going to think, well, I think a chemical reaction happened here. I think the physical properties completely changed. All right, so have fun playing with your slime. If you're going to do this, and you can do this at home, a lot of people have borax. This is easy to get. You can get this at the grocery store. You can get this probably at Walmart. You can get this basically anywhere. You can get groceries and washing detergent. It's also good with stains in the laundry. Kids do laundry. So play around with it. Have fun with the reaction. This one wasn't a big boom, but again, it's pretty cool. So until next time, wash your hands.